Greetings, Benjamin J. from BENZTRAINZ with another in the series. Well, doing another experiment with the battery. It's 3 a.m. I have been in the train room virtually all day long. Anyway, I've got the meter hooked up to the rail. I've attached a second lock on so I can read the power actually coming off of the rail. And as you see, the meter is reading 001 volts. 0.001. So no voltage at all. Anyway, on the track, I have the LIONEL 2025. I put a fairly heavy consist on it. 14 cars, some of the heaviest ones I have. And we're going to see what kind of voltage it takes to run the locomotive rather than the current. So we'll turn the controller on. I'll just point it at the meter. There's 6 volts. Bring it up. See how much voltage it takes to run this. We know the current now. So there's about 8 volts. As you see, good constant speed all the way around the rail. .8 volts. Take it a bit faster. Okay, there's 8.1 volts. So a good constant speed, about 8 volts. So 8 volts at 1 amp. We know what the current draw is. Now we know what the voltage draw is. So this is running fairly decently at right around 8 volts. So there's more than enough power in this battery. We have 12 volts available at 5 amps. So as you see, about 8 volts gives you a good constant speed all the way around the rail, pulling 14 heavy, fairly heavy LIONEL cars. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So voltage is staying current, or constant. Speed is staying constant. We know what the current draw is, about 0.9 amps. So now we know it takes about 8 volts to run the 2025 pulling 14 cars. So again, it just goes to show that this battery has more than enough power to run this thing for really as long as you care to run it. No one's going to stand here for 5 hours and run this locomotive. So 8 volts at 1 amp, approximately. As you see, that's running at a good constant speed all the way around the rail. Headlight is on, pulling 14 LIONEL cars. As you see. Anyway, I was just curious as to what voltage we were using. I did lots of videos last night on current draw. So now I just wanted to see what the voltage, actual voltage required to run at a constant speed. So 8 volts gives you a good constant speed all the way around the rail. You can run it a bit faster. Let's take it up to 9 volts and see what happens. So there's 9 volts. That's clipping right along at 9 volts. As you see. So that's more than fast enough, no doubt. This is a heavy locomotive. This is the heaviest one I have. Let's go ahead and slow this down. So again, I was just curious to see what the voltage required is to actually run the 2025 with 14 cars. Like I said, this is heavy. I haven't weighed it, but it's got to weigh 4 pounds. I mean, this thing is heavy. Maybe I'll bring a postal scale up here and actually weigh the 2025 and the 2036. That'd be a good idea to know exactly how much weight we're moving. It'd be actually nice to weigh the consist. It's just time consuming to have to weigh all these cars individually and then add it all up. Anyway, I just wanted to do a quick video on the voltage required to run a 2025 pulling 14 cars. So I've never seen this done, so I had no one to ask, so I had to do it myself. So we know it's pulling 0.9 amps. We know it runs more than fast enough at 8 volts. It runs very fast at 9 volts, and we have 12 volts available. So as you see, these batteries are more than sufficient to run a model train. So an interesting experiment. Just wanted to document it. As always, if you have any questions, feel free to drop me an email, benztrains@gmail.com. And as always, thank you for watching.